Hello, I'm Jackson Wheeler, and I'm a computer science major at ERC College.
Hi, I'm Sidharth Srinath. I'm a Math CS major at Warren College.
We developed a program that can teach itself how to play the snake game. The snake game is a game that can be programmed in Python in which the user presses down the arrow keys to move the snake. When the snake eats the white squares, his food, it grows in size. Now the two ways to lose are by hitting the edges of the game window or running the snake into its own tail.
Our goal with this project was to develop a program that can learn to play the game and can progressively reach a point where it stops making mistakes, and we try to achieve this through reinforcement learning.
Utilizing the NEAT library, we were able to run the snake game with hundreds of snakes playing at the same time. By inputting information about each snake's surroundings at each frame of the game, the NEAT library was able to consult that snake's neural network and tell us which way the snake should turn. At the beginning of the program, we spawn hundreds of snakes with slightly different neural networks. As the snakes die off, the ones left are the ones who, by chance, have a genome that allows them to do better in the game. Then, the program takes these snake genomes and reproduces them to create a new generation of snakes. This process is repeated so that eventually, by survival of the fittest, we will be left with a population of snakes that excel at the game.
Our program was ultimately unable to reach its goal of playing perfectly, and that was due to one main shortcoming that we will discuss towards the end.
We found a snake game created using Python on GitHub, which we utilized with our algorithm. We had to refactor the code slightly by creating classes for the snakes and the food and adding other functions. However, using this code was extremely helpful as we could focus on implementing reinforced learning without having to create the game from scratch.
The three main things that we need in order to get the NEAT module working are the configuration file, the fitness function, and the run function. The config file allows us to control hyperparameters like the number of inputs, outputs, hidden layers, the population size, and the activation function for the neural network. The fitness function, which in our case was our main game function, is what we use to evaluate the fitness of each snake and return it. The run function is what feeds our game information and configurations to the NEAT API in order to apply the genetic algorithm and pick the best of the populations. The first version of our AI kept running into the walls and dying. It was unable to make a series of movements oriented towards the food.
To fix this problem, we had to change the inputs that we were putting into the neural network. Instead of giving the X and Y position of the snake and food, we altered our inputs to give the current surroundings of the snake based on its orientation. This change, finally, resulted in the snakes learning to go after the food.
The last problem we had, which we were unable to solve, was to stop the snake from running into itself.
We took many different approaches to this problem, including inputting the snake's current distance away from its tail. However, this still did not solve the problem.
We also tried to implement a gradient of reward in which the snake is rewarded for moving farther away from its body. And we also tried classifying all obstacles under one input, and only input the obstacle that was a more imminent threat at each frame. And that still did not work.
One thing we realized is that oftentimes when we tried to improve the snake training, we just ended up making our program perform worse.
In the end, we were able to create an AI that can play the snake game pretty well. Thank you for listening, and a big thank you to all the professors and mentors who made this project and all of SPIS possible.